Hello everyone, here's Jiayi and this is my homework 10 question 2 presentation. In this question, uh, we need to explain my understanding about these properties of the stochastic processes. And the first property is the WSS, which is wide sense stationary process. Its wide sense is not so strict. So the wide sense stationary process is just two basic formula. The first one is we need to uh, know the expectation of the process is constant, and then we need to know the R uh, can be right as the R of tau, where the tau is the difference between the T1 and T2. So if a process with these two properties, then the process is WSS process. Right. With this property, the first of these two properties is really easier than the second order mass, because sometimes the second order mass function is really hard to find. So based on this, we can get a lot of estimation in MS sense. And the second property is independent increment process. It just like its name. The non-overlapping interval of process is independent, so it means independent and is increment, right? So we have learned the random walk, Poisson process, Wiener process is all the independent increment process, right? And the third property is Markov process. Markov, just like Markov chain, the property of xn based on xn minus 1 is equal to alpha, maybe some constant. So the main mind is the future status only be influenced by the present status, nothing with the past. Yeah, so we learned the random walk and Wiener process, they are Markov process. So the fourth normal process is really simple, because the definition is this process function about the x and t. T's time is okay, but the x, we need to ensure every x is a normal distribution, and finally the process function is this, is joint normal. So the eta is the expectation of x, and the c is this. Just be normal. And the fifth property is strict sense stationary process. The fifth is different with the first, as the first is wide and the fifth is straight. So we have to focus on the basic line, the process function. Uh, when the x is the same, but the t, we can change the t. We can move the process, uh, shift to before or shift to later. So the process is same when shifting on the time axis. That's, uh, that is the strict sense stationary process. And the third is white noises. White noises, just like we can uh, just get the derivative of WT. WT is linear process. And we got this. This is just like the noise in the real world. The noise influence on the some maybe some signal. The influence, the expectation of influence is zero, right? The noise, voice noise is not some meaning signal because it is just up and down, right? So the expectation of influence is zero. And R is just about the two-time itself. The seventh is mean ergodic process. It's just one definition. Is the expectation of process is equal to this. Just with the t near to infinity, and we can get this integral in MS sense. And it is martingale. It is really a really likely about the Markov process, but it's different. This one is I can just less than or equal to the n. Don't need to just -1, right? The Markov is just the present, not the past. This is whatever present and past. But it must be the it's actually like a start base for specific interval, like between the T1 and T2, we just base on the T1's basic for T2. So the expectation of T2 based on T1 is equal to the value of T1, not value, the value of xt1, right? So that is martingale. We learned random work and winner process and so on. Alright, that's all my understanding about this property. Thanks for watching.